This will be our third and final video on balancing redox reactions. This one will be balancing under basic conditions. Before you get going in this video, you probably should have already watched the video on balancing in neutral and acidic conditions. We will use those skills and build off of them to work on basic condition balancing. So the overview of this video is relatively quick. Again, we're going to go a quick refresher of what redox reactions actually are. We're going to talk again about those balancing rules. If you guys have already seen the other videos, you don't need to take notes on this section. Again, it's the same stuff all over. We'll just be highlighting the differences we're going to be focusing on when dealing with basic situations. Last but not least, in the majority of the video, we'll cover a couple examples doing basic reaction balancing, and then that'll be pretty much it. To fold in ideas from earlier in the chapter, it makes a big difference when balancing redox reactions the conditions that you're under. And we've identified three scenarios. Neutral and acidic we have already talked about. These change the conditions as to what elements are available to help you balance. For example, in acidic we have excess H+ ions. We're going to be talking today then about the third of the three, how to balance under basic conditions. And here we'll have excess OH ions, and we'll talk about how those can be used to balance your reaction. Down below again we have our pH scale. Neutral means we have a pH of around 7. Below 7 we're dealing with acidic substances. This means we have excess H+ available to us. Alkaline or basic means we have excess OH-. And here again is our rules. I'm not going to take some time to go over these because I feel like these are rules we've seen a couple times now. If for some reason you don't have these written down, please make sure they do get written down. And I believe at the bottom of the page there's a printout of all of these that you can have handy to save yourself a little bit of writing. The new rules we'll be talking about happen right here, and that is rule number 6. Rule number 6 tells us that we're going to add in OH ions to the side of the reaction that contains the H+ ions that we added in previous steps. We do this to neutralize the H+ because we don't have H+ in solution. We have OH-. That turns them into H2O molecules, and then once we get past that, we're going to go right back on to our steps that we worked on before. We balance the half reactions by balancing electrons for both sides. We recombine them and cancel out unnecessary chemicals. Just to take some time to clarify what these new rules mean, I want to focus on the fact that it is exactly the same process for balancing as we did under acidic conditions. You're going to do all the same steps, but the catch is right here. We cannot have excess H+ ions left over after the reaction is done. Basic conditions means that there is no H+ available. So to fix this, we're going to do one extra step, and that's the step we just talked about. Wherever you have H+ in your reaction, you're going to add OH- ions to cancel them out, but we have to do that to both sides of the reaction. So I have to add in 7 OHs over here on the right. I have to add in 7 OHs on the left. We do have excess OH in the solution because it's basic conditions, meaning now we're correcting our reaction for the conditions we're under. Adding to both sides does not change the balancing, which is why we had the same number of OHs. And the reason we do this is because the OHs cancel out the H+ and turn them into H2Os. What we're left over with is all of our H+ canceled out and gone. We'll have an excess number of HOs somewhere in the reaction, and we'll have an excess number of water somewhere in the reaction, all of which is okay when you're dealing with basic conditions. So let's put this all into gear. I have a reaction right here that needs to be balanced under basic conditions. If you feel like you have a good grasp on what it is you need to do, by all means pause the video and give this a try. I'm going to go over this one together in a couple seconds, and then we'll talk about, I'll give you another one after this that you can give a chance to practice on if you feel like you needed to see it first. So let's start taking a look at some of the answer here for this particular reaction. Up top you can see that I took some time to identify the oxidation states of either one of those. That's telling me that manganese is being reduced and the carbon atoms are being oxidized. What I've then done is wrote out the two half reactions here in red, and then I balanced this reaction as if it were under acidic conditions. I added in 2 waters on this side to get the oxygen necessary, meaning we have an excess 4H+ over here, and likewise I added in 1 water over here to balance balance out this oxygen, and that required me to put in two H pluses. To make this reaction under basic conditions, then, we have to then cancel out the H pluses. That's the new step. So up here, if I have 4 H pluses here, I'm going to add in 4 OH minus to that. These two guys are going to cancel each other out and turn into 4 H2Os. Now, if I add in 4 OH minuses over there, I've got to add in 4 OH minuses over here to ensure that my balancing stays correct. Likewise, down here I have 2 H pluses, which means I'm going to add in 2 H2Os. Sorry about that. I'm going to add in 2 OH minuses over here. The OH here is going to cancel with the H plus here to make 2 H2Os, which means I also need to add in 2 OH minuses on this side. I have now balanced the reaction under acidic conditions and then corrected the reaction to make sure that it is now balanced under basic conditions. At this point in the game, recombining everything is just like it was before. We're going to get the number of electrons on both sides to be the same, and then we're going to combine this back together into one final reaction. We've now taken the time to combine the two half reactions into one big reaction again, and now it's time to cancel out excess substances. The thing that should always cancel out if you've done things properly is the number of electrons, and I do indeed have 6 electrons on both sides, so those will cancel. Waters are often a very common thing that cancels as well. We have 8 and 3 waters on this side to make 11. We have 6 and 4 waters on this side to make 10. That means all of these are going to cancel out. And that is going to leave us with 1 H2O when everything is said and done. And I believe that might be it. The last step is to take this, rewrite it as one final reaction. And there we have our final reaction completely balanced. Again, we just took whatever wasn't canceled out from up here in this step and rewrote it down as a final step here. Here's a second example for you to try. Again, now I do recommend that you pause the video now that you've seen one of these done. Give this a try. Again, balance it under acidic conditions, correct by adding in OHs to both sides, and then continue the process by recombining, or balancing for electrons, recombining, and writing the final reaction. Again, I'll put the answer up on the screen in a couple minutes. So here's the work that I ended up doing. Again, I started by assigning oxidation numbers. I recognized that the chlorine is reduced and the chromium is oxidized. I balanced by adding in waters and H pluses in blue on both parts. I canceled those out by adding in the corresponding number of hydroxides to both sides in both cases. Those hydroxides cancel to form waters here. Once I've gotten all these things figured out in terms of H pluses and OH minuses, I recognize that I need to double the number of electrons in the second reaction. I do all that, write it as one big long line of chemicals, and then I canceled out in blue for everything that wasn't necessary, leaving us with this reaction here as our final answer for this particular problem. So to wrap up, you should be able to do pretty much all the things you've been asking you to do for the last couple of videos. The only difference is this last step here, is being able to balance redox reactions under basic conditions, adding H pluses and H2O atoms to balance things out, and then finally adding OH ions to cancel out your H pluses, turning them into H2Os, making the conditions that we describe match the balancing techniques that we use. This is definitely a process that requires a significant amount of practice. As you probably already noticed, there's a lot of individual steps along the way, a lot of places to make mistakes. The more time you can invest in practicing these problems, the easier and easier they're going to get.